Yeah, there's a now. Okay, you're good to go. Just give it an intro.
Okay. Thank you. So, okay, the last step that we need to discuss is the grid code compliance. Now, before I continue here, who can remember where in the grid code compliance, and this is for generators really, what responsibility does the distributor have? See who did listen in the previous 2.5 days. Okay, so in my opinion, this section is almost for interest's sake. It's to sensitize the people to what is typically required. Very few of these are the responsibility of the distributor. There's only one thing that really, from what's in here, that's really important for the distributor. All right, note takers. So let's see, we'll get to that. So we have done an overview to the grid code on day one as part of the regulatory framework. We have discussed the difference between generator, embedded generator, and what I now call behind the meter EG. So the generator is typically connected at the higher voltage levels. It's not distribution connected. Embedded generation is by definition of the grid code connected to the distribution system. Behind the meter is something that's not yet defined or addressed in the grid codes. But I would, just to separate that from embedded generator, I've added that as terminology. So basically the grid code gives requirements for the generator to support the network. These requirements are tested at the beginning, just after commissioning, and then there's every 6 years that the compliance has to be proved again. So there's a few steps, or there's a sequence to the grid code compliance, and that's what we're going to basically look at. We have discussed that. We've discussed the differences between the customer, prosumer, and the generator. And one thing that I do like to share, I've got two small networks that I've just shown here. So for the one, we've got our point of connection either here above the transformer or at the low voltage side of the transformer. And the other one, the point of connection would be at the generator. Now, from a technical point of view and the impact on the network, I don't see that there's any difference between these two installations. This one would automatically be fully bound by the grid code. Nobody questions that. This one, there is ambiguity in what the grid code requirements are because it's now behind the meter. So there's a load customer also connected. So the proposal is, and we have it also from the grid code secretariat, that it gets implemented that this generator gets assessed at that point because the grid code applies at the point of connection. Okay, so the basic steps that a generator would follow is that there's the feasibility part of it. And that's not really part of grid code compliance, but it is informed by the grid code compliance requirements. So that's when the generator starts thinking about whether he wants to install a generator and what's it going to entail. Once he's gotten to that point, he's got an idea of what size he's got or he wants to install. He started speaking to the distributor where he's going to connect. And he's probably got the go-ahead that that's possible from the distributor. So the distributor either has capacity available, or the customer is happy with the cost estimate letter that he will be able to afford connecting to the network. Then they should start with the grid code compliance simulations. We will talk about what those entail. That also informs the design, because they have to now make sure that they're going to meet all the grid code compliance requirements, and that they can prove at this point via simulations. Now, then there's a few steps in between these. Of course, the design is done, and then they start with the construction. The commissioning, we've now just discussed. What does the commissioning typically entail? But usually during commissioning, they would go through so-called dry run tests, which in essence tests all the requirements of the grid code before RETEC is called to come and witness these tests. So at that point, they can already prove that they're compliant, and it's easy during commissioning to adjust any settings that might need to be adjusted to actually meet the grid code. The power plant or power park controllers, very often you might need to set a ramp rate, or you need to set the trip threshold or something like that, which you will pick up during a dry run, rather than doing it during compliance testing, because then RETEC is probably going to tell you, you're wasting my time and you don't get your compliance, and they have to come back, and that will just delay the process. So make sure during the dry run that you can do everything. And then the compliance testing is with RETEC in attendance. That is the one part that we are not sure that RETEC will be able to do. After the compliance testing, you've got your, shall I call it, provisional grid code compliance status, and the plant would be allowed to generate and remain connected to the network. That obviously assumes that at any of these stages, from commissioning up to the compliance testing, nothing serious was picked up. So there's no safety concern, and there's no technical performance concern. So during this stage, you actually, in that 6-month window that we spoke of earlier, you're going to look at the power quality. Somebody's going to measure it and assess it against the requirements in the grid code. That report will be submitted to you as the distributor, because RETEC doesn't sign off on it. So the distributor has to now review the power quality compliance and advise RETEC that they accept it, if it is obviously compliant. If it's not, that also goes back to RETEC, and the generator is informed that there is a non-compliance, which they have to fix. And the timeline for that is typically, it's a year or 18 months, because for power quality, to design and install a filter could actually take quite some time. The generator will have a temporary exemption during that period. Provided that there's no significant negative impact on the network at that time. So, for instance, you're not causing major harmonics at a neighbor whose equipment will start to fail due to that harmonics. In parallel with this power quality testing, there is developing so-called RMS or phaser type models, as well as EMT, that's electromagnetic transient. That means you actually, in the simulation package, create the physical waveforms that you would see on site. So that 50 Hertz waveform with whatever transients on them, these gets developed at this point. I think there's also a year to submit them from the initial compliance testing. One of the possible problems is that in order to validate these models, there must have been some other event on the network, and that must have been captured by a transient recorder, which many power quality recorders can also do. And that has to be used to benchmark the actual model versus the simulation model. So there's a validation process. These models get submitted to RETEC, and Eskom, the system operator, will review them and then issue the compliance status for that plant. But these last three steps happens after the plant is already operating commercially. So it's not dependent on these for the plant to actually operate, unless there's a negative impact on the network, in which case it can be switched off. Okay, so the simulations, there's an example. It's a guideline for wind energy plants, is that you model your entire plant. In yesterday's presentation, I had a PV plant similar. And you're going to, at this point of connection, prove that this whole installation will meet the requirements of the grid code. So what are those requirements? It's basically the plant must continue to operate if the voltage at the point of connection is within these ranges. And yesterday we had the 33 kV example. It is actually plus 8%. So that plus 8% would be at this point of the plant. And it means that all the equipment at the furthest ends, this voltage must not be too high that the customer's generating equipment gets damaged or trip off, for that matter. What is implied here is that as the distributor, the voltage at this point shouldn't exceed these values. Right, then there is a requirement that the plants must remain connected at different frequency ranges. They're allowed to trip off if the frequency goes too low. That's typically to protect the plant. Inverters typically don't have too much of an issue with the lower frequencies, or not as much, but any rotating generator might have quite a problem with it. It puts too much mechanical strain on the physical generator. High frequency, that is a problem because that means there's too much generation in the system and too little load. Not something that I think we'll see very soon in South Africa. So in terms of these simulations, the responsibility of the generator or the customer is to confirm the voltage ride-through requirements. I'll show you. Well, let's go to the graph. For those of you who haven't seen it, category B and C must be able to remain connected if the voltage drops down to 0 at its terminals for up to 150 milliseconds. Now, for anybody who's used to power quality, I've just overlaid the dips on here, so you get an impression of what kind of events this generator must be able to ride through. And then, so in this area, they must remain connected. And within 1 second after it clears, they must operate with full power again. Category C also have to withstand this over voltage area. Then active and reactive power and voltage control capabilities. The main reason for that is that the reactive power can be used to support voltage control. And that is something that the operator can request of the generator. So either the distribution network operator or the system operator. That's another question that we don't have feedback from Eskom yet. Which size generators do they want all of this information for? And do they want to be able to control? Dynamic reactive current support, that is during these kind of dips, the request is that the generator actually injects reactive power to assist in supporting the voltage so that you reduce the magnitude of these dips. Tolerance of frequency and frequency support, that links back to the previous graph. So that's the customer's responsibility to prove via simulation. The simulation report ultimately should be signed off by RETEC. The distributor's responsibility is that the rapid voltage fluctuations are not going to be excessive. This forms part of the simulations done for the grid impact study. So what is the impact of this generator on your network? That's also, I don't know if you recall that what's that acceptable network impact. This links back to this rapid voltage fluctuations or changes. So if the network isn't actually strong enough for this generator, it's the distributor's responsibility to propose the network strengthening so that you're not going to have a problem. Short circuit studies are required to make sure that equipment withstand capabilities are not exceeded, as well as for the protection coordination. So that's an input for protection coordination. And this protection coordination links back to a lot of that integration standard that Andrew spoke of yesterday. We've looked at the voltage right through. Then the voltage right through, at least South Africa has got a slightly better requirement in that this is supposed to apply. Okay, no, sorry, that's not. You are going to test the voltage right through for starting at a high voltage. So for instance, starting at the upper limit of the voltage range or even the low voltage range. Now, either one of them can have an impact depending on how inverters, for instance, are set up. One thing could be that if you started at the 1.1 per unit and it drops by down to 85%, the inverter might actually think you've gone down to 85%, which means you sit in this area, just because it looks at the size or the magnitude of the jump rather than the actual voltage at the point of connection. So that's why you do test it at a range of scenarios. And this is also for different reactive power set points. And the reason this one isn't a proper square is because when the voltage is already low, you really shouldn't require the generator to absorb reactive power because that just exacerbates the under voltage problem. The same with the high voltage side. You don't want them to inject reactive power because that will just maybe increase the voltage, and that's not necessary. Okay, so these points, you are going to simulate the following graphs. This is just to say that category B, you must be able to operate at reactive power that amounts to a power factor of 0.975 at the full power output. If they operate on a constant power factor, it's these two lines here. But they must be able to provide the reactive power down to 20% of the active power output. So they must be able to actually operate at a worse power factor than the 0.975. And here at low power outputs, there's strict requirements. We have looked at this graph just now. Category C, there's a slightly bigger requirement. They must be able to operate at a power factor of 0.95. And in essence, this means that they can give better support to the network in terms of reactive power requirements. Just to show you what graphs could look like, is that this blue trace is the requirement from the grid code. And in this case, the plant can actually give this much reactive power, both positive and negative, when the plant is at zero output power, and it can meet all the requirements of the grid code. Now, each individual inverter, for instance, and also most wind generators would at least be able to do this blue curve. But the moment you add them all together, along with the collector network, this changes, and this is why the red curve is around it. And this was done at different voltage levels. And you can see that for the low voltage starting point, it actually clips this part here. So in this case, the generator has to see that he has to adjust his design so that he doesn't clip the corners there and is fully grid code compliant. So he has to now either take a different inverter or add a few inverters or something like that. The dynamic reactive current support, this is just, like I said, if there is a undervoltage or dip event, it must be able to, for instance, inject reactive power to support the network. If there is a voltage, an overvoltage event, it must absorb reactive power to once again assist in reducing that voltage. And there's just some examples of simulations for there's a dip and how the reactive power was adjusted by the plant to meet the grid code requirements. Then the frequency support, the biggest concern from utilities, and that's more the system operator, is that over frequency conditions, this means there's an imbalance between your load and your generation. And at some point, also your rotating generators will become damaged and you want to reduce the generation. Now, if you've dropped your generators down to their base load and you can't reduce it anymore, renewable power plants also have to play their role. And for those who haven't heard this story before, originally this just said, let's say, for instance, at 50.5 hertz, the embedded generators must disconnect. And when you get to a point where you have a high penetration of renewable power plants, this can actually cause instability, which is what Germany had experienced on a nice hot summer's day when the load was not high because everybody was at the beach. And suddenly all the generation tripped off and their system nearly collapsed because then the generation dropped so quickly and so much that the base load generation couldn't support the network. And I think the saving grace for Germany was that they're part of a very strong interconnected network with their neighbors. So the proposal here is then, instead of just switching all of the renewable generation off at the same time, they will start reducing the active power output. That then trip off at a higher point, but that should, at least you should not exceed that point, or it's less likely to exceed it. This is an example of how the frequency response was tested. We have spoken about this. That's just a summary. Short circuit studies and RVCs and protection coordination is on the distributor side of responsibility as part of the grid impact study and evaluation. Ancillary services is really something that becomes important now with the higher penetration of renewables. Let's show it on this graph. It's been part of the grid code since the start, and it's now being enforced for new government procured IPPs. I do suspect that all new generators, embedded generators included, would be more stringently assessed on this. And it just means that you must be able to, in essence, leave a spinning reserve on your generator side. So leave that something in reserve in case the frequency starts dropping, because another one of Eskom's power plants have tripped, and you can support the network by providing that virtual inertia. Just an example of how quickly the plants can do this. Now, inverters can do it very quickly, and you actually have to set down, reduce the ramp rate for the inverter. This power electronics is this very powerful component. Now, the compliance testing, there is that spinning reserve test, delta production, active power gradient. So this is just, I didn't speak of it. This is how quickly they can increase or reduce the active power. And there are cases where you don't want that to change too quickly because of especially the impact on the larger system. So you just must be able to set this. Power curtailment during overfrequency. This can be tested. Sorry, compliance testing. Let me step back. This is the physical testing that occurs after commissioning has taken place. And this is also what you would do with a dry run test. That should be part of the compliance of the commissioning. And this is what will be tested when RETEC comes to visit and ensure that you are grid code compliant. Then the reactive power control function. Can you control the power factor, and can you control the voltage? Those are all requirements in the grid code that the generator must be able to set in different modes. And you can set different droop values. And then the SCADA integration. So can you receive the signal from whichever system operator or network operator? Because you have to then return that I've received this. I'm going to implement this from the generator point of view. Then the power quality, we've already said that's something that gets measured after compliance, commissioning and the basic compliance testing. It's Appendix 13 of the document. RMS models, we have discussed, it's necessary for the system operator to know this, especially for the bigger plants, because that affects the potential stability of the network. And Eskom needs, or the Eskom system operator needs to know what's going to happen if the next generator trips, especially now that so many are already out of service. Each generator that trips at this point in time brings our system closer to instability, where the frequency will drop too far and all the generators can trip off. So yeah, that's, and typically the renewables don't really support the network quite as much as we want. All right. So that was just meant as a information session. This is typically what the generators need to do. If you want to do your own generation, these are basically the steps. This is not what the distributor is going to sign off. The key parts there is during the grid impact assessment to make sure that the network is strong enough for the generator, issue the power quality requirements, and make sure that the protection and, where applicable, communication is set up. That would be the distributor's responsibility. Okay, any questions or comments here?
Could I ask that you just comment on one thing, Gerard, and that is, we know there's certain areas where the grid code seems to be not appropriate for smaller generators. Like if there's a mall with 1 megawatt on the roof and they want to add another megawatt or half a megawatt or something like that, suddenly the whole grid code compliance thing kicks in and ESCOM standard, generator standard kicks in. But just on the grid compliance side, can you sort of flag a couple of aspects where you think it might need modifying to be appropriate for these smaller generators? So you're asking a 1.5 megawatt generator to support the grid in all sorts of ways that you've just discussed. And then the SCADA thing as well. Could you just comment on that? And I know that you are sort of starting to look at engaging the grid code secretariat around changing the grid code, but I think it's just important to flag a couple of those areas. I wonder if you could do that.
Yes, thank you, Mark. I didn't speak of that as much. I think one of the key concerns in the first place is identifying what is appropriate behind the meter. Speaking of where it's assessed is one aspect of it, but what is really appropriate if there's mostly self-consumption? Remember, the network still sees the changes should the generator, for instance, trip and the load doesn't trip off. So maybe there's not too much that's going to change. But specifically on the SCADA and possibly being able to dynamically operate, go to that graph quickly, operate anywhere in this area. I think those things are, especially up to 5 megawatts, probably not as applicable. One can, from the grid impact assessment, decide what should be a reasonable point for this generator and just inform them to operate there. This is what ESCOM in any case does. They seldom do this dynamically. They get a standard set point. This is where you operate 95% of the time, but the system operator can still tell them, listen, please change it now dynamically through the SCADA. So for the smaller ones, I don't think that would really be appropriate. If that needs to change due to something changing in the network or a contingency, you should be able to phone up the owner and say, listen, tell your operator to just adjust this, and that can happen in an hour's time or so. It doesn't necessarily have to happen immediately. That's the one thing. So that would also reduce the requirement for SCADA and a lot of those additional costs, and even the municipalities very often don't have SCADA. Just get back to take this slide as well. Then the RMS models and the EMT models. That is also something that probably up to 5 megawatt is not sensible. The system operator is not going to look in detail at how each one of these generators react during a system disturbance. We just don't have powerful enough computers to do that. Nowhere in the world. So that's probably totally redundant, and that adds quite a considerable cost component for the generator. The power quality is already simplified for up to 5 megawatt. I think those are probably the key parts that I can think of now, that I can remember now.
That's great, Gerard, thanks. And then just to say that there is a process to try and engage the Grid Code Secretariat, I think, around making the grid code, because the grid code applies legally, I think, as you have said. So at the moment, a 1.5 megawatt generator would have to comply. And there are these areas which are probably not appropriate. So there's a process in place to try and change the grid code so that it is relevant to all of these things. And then I just see there's a question around harmonics in the chat, Gerard. You might want to, Jan, comment, or a question from Jan on the harmonics you might want to address.
Okay, before I get to that, sorry, Mark, I just opened this other document. Something that we also say is this whole thing about RETEC actually doing the sign-off. Is it going to be feasible, and is it sensible to get RETEC to come and sign off a 1.5 or a 2 megawatt plant? That's the one question. There's also maybe clarifying the role of the distributor in signing off these. Yeah, those were all. It's really about RETEC's capability, and should any of that responsibilities be delegated to the distributor, which is not necessarily recommended, or can we propose that, for instance, a professionally registered engineer sign off on that? Okay, power quality question. It's up to the 50th harmonic as per the grid code. There are, I would probably like to see it up to the 60th harmonic. Most power quality instruments can measure that, but there is research work being done on different levels for above 50, the 50th harmonic up to 9 kilohertz to get appropriate emission limits and compatibility levels there. But at the moment, just the 50th.
How did you see that question, which Mark posted from Ishmael? I saw it on WhatsApp.
Oh no, I haven't looked at WhatsApp.
No, it's the same. It's just asking the grid code requires control functions, even for category A3. So that's obviously 100 kilowatt up to 1 megawatt installations, unless exemption or revision required. So I don't know if you want to comment on that.
Okay. Yes, the grid code does require that, which implies there's SCADA from, well, to the generator's terminals, to which he must be able to respond. I think it's only basically a start, stop, and something else. Maybe we haven't spoken about the exemption process and the amendment process, but that's in the, yeah, one of the grid codes. I can't remember now what the title is, but there's a process where you approach the grid code secretariat with either a request for an amendment or a request for exemption. Now, in practice, there's a process for a permanent exemption, but in practice, I know that there are no permanent exemptions except for some of the old Eskom plant, which was designed and built long before the grid code was written. Any of the renewable generators only get temporary exemptions, and that means they have between 6 months and 2 years to fix whatever problem and become grid code compliant. But yes, that's also debatable whether that's applicable. Okay, anything else?
Any other questions or requests? Gerard, you are done now with the lessons, right?
Yes.
Okay, would you mind just quickly checking the documents I've sent you? That's for the exercise. So the next step would be to make the resources available for the assessment. And then we can just finalize that checklist. The idea would be to remove the steps which is relevant to the distributor, to the developer, to focus that's relevant to them. So, but yeah, you can maybe just quickly check that. Are there any other questions or comments from the audience?
Hi, Farah, can you hear me?
Yes, we can hear you, Ishmael.
Sorry, man, I don't know why I can't put something in the chat box here.
Yeah,
Or raise my hand, but nevertheless. Maybe, Gerard, just to come back to this discussion in terms of the SCADA requirements, this is quite a big debate from a customer perspective. And like you've now mentioned, that this requirement can most probably be waived, but that's why I specifically mentioned that because of the grid code, we sort of feel that, you know, we cannot do any waiving because it's a grid code requirement. And I mean, even for the poor A3 category customers, they currently providing this for us. And we've had discussions with some of the Eskom staff, and I know they're not even doing it for the A3 categories, simply because they just don't have the means to do it. But not to say that it's not possible. It is possible, like I said, because we've been doing it already. But it's just that Eskom hasn't sort of embarked on that yet. So it becomes one of those issues in terms of it is possible, but do you want to continue with it, and what's the benefits from it? And as Reino always say that, yes, you might want to say it's small connections, but at the end of the day, all these are is adding up and making a full basket of things. So that's where the network control guys comes and say that, yeah, at the end of the day, if they all are they going to contribute, they need ways and means to be able to curtail or to intervene from a network perspective and a grid stability perspective, if and when needed. So it's those type of debates just in the A3 category that's already sort of, you know, becoming a problem. But we still insist that they actually provide it, and because, like I say, there are ways and means to do it, that they do provide it. And then on the greater than 1 MVA, the requirement becomes even more stringent. It's definitely required there. No debates, and they would need to provide a protected substation building to be able to facilitate that in terms of the SCADA, because that's the a easy way to be able to facilitate it, and not with, for example, you know, your old outdoor ring main units. Okay, we know the newer ring main units do have the ability to add SCADA facilities, and that's also another debate in moving forward. Will we now allow that and not insist on a protected substation with proper control switchgear that can facilitate the SCADA requirements? So yeah, it just becomes obviously a cost issue on the customer side as well, to be able to facilitate these things. Thanks.
Yeah, thanks, Ishmael. I think you're obviously not the only one. Eskom also sits with similar scenarios, and we really need our regulator to come to the party to address these issues. So, yeah, for now, legally, the grid code says this, and where there are gray areas, it's going to be open for discussion. I can see that there are going to be people who's going to want to take these things to court, but they shouldn't threaten you with that. They should actually go back to NERSA, you being the distributors.
Yeah, I guess on the SCADA side, given that the vast majority of municipalities don't have SCADA and probably are not going to get it, one needs to put in some conditions with the generator that if it is enforced in future, or maybe the SCADA will connect directly to Eskom or something like that. If it is enforced in future, they will need to respond, but probably not worth stopping them. I mean, the country doesn't want to stop them going ahead, so we need to facilitate the process and make sure it can go ahead, even though municipalities don't have SCADA.
Yes.
And then we'll sort this out over time. Yeah.
But yes, the SCADA should be checked during the grid code compliance, and we can only request feedback from our regulator on that and RETEC. Okay, so we've got the example from eThekwini. There is an application form. There are some reports, some settings reports. So the proposal is that we make this available to you now. And then for the time being, let's get this guideline up on the screen, is that what you should do is to actually go to this checklist, Appendix C, and start going through this as if that's an application on your desk. So let's assume there's somebody who's resigned from your municipality and you've got this project handed over, but the checklist is gone. So you have to now look at all the steps that's been done. Where are we in this process? And now this application, as far as I know, isn't at the final step yet, so that they haven't signed off on everything. There's again a Google form that you're going to complete, but it might be useful for you to just open this document and copy this or make a copy of the document and just tick it for yourself as you go along through this process, which you can then transfer to the Google form in one go.
Gerard, we can make
Yes.
a Google form available unless you wanted to make some edits first or wanted to check it.
No, I don't think that's necessary. It might just be easier for people if they can refer back to this as well for themselves.
Okay, good, very good. Okay, I think also, Gerard, as you complete the checklist and there's specific information which you do not find in the documents provided, feel free to ask that. It might be that it might be information that we need from the utility side, and I mean we've got the eThekwini guys here, and they can say yes, it's done, it's not done, or we don't know. So and then we'll put that all on a presentation, on a slide. That specific information as we see what's missing. So, but at least the idea is to apply your own mind, to go through the document, see how much you can complete, and then if there's something that's not clear or you can't find it, then you can ask it. Something else I would also just like to kindly request. First of all, thank you for eThekwini making that application available. We really do appreciate that. We have tried our best to anonymize it as far as possible, removing the details from who the customer is and contact details and the developer's details but we would like to plead with the people participating in this activity to only utilize that document internally for the purpose of this exercise. Do not use it externally or share it elsewhere. If that's just a request from our side, so that we can all learn from it, but not cause any headaches or issues going forward. So just a request from our side. Gerard, let me know when I can share that link to the resources.
Yeah, so I think you can share that link. My proposal is we've done small examples over the past 2.5 days, where we've said, okay, this, and you've basically completed this checklist for that example at hand. And we've had some questions, oh, but this isn't available or that isn't. And that is why I recommend that you do go back to the checklist in the document so that you can continue as you have the information and come back to questions that we might only answer after lunch. And then after lunch, so you can start with it now. After lunch, we can have maybe give you another 20 minutes or so to look at it, but we will be here to answer questions along the way. And if there's any part of it that you are unsure of, but why do we ask this? Or what does this specific checkpoint actually entail? Let's have that discussion. Okay. And then after you've all submitted your forms, we can go through it. And is there time for that? Did we allow for that for it?
That would be all part of the activity. So
Okay, yes.
Going through it, doing the checklist and responding on it as we go is all part of the time allocated for that.
So I think,
ask
yeah.
a question quick. So I don't know if there's a grid impact study as part of this. Now, we haven't covered that in detail, obviously. So some people might know enough about it, and that's the subject of other training. But I can imagine people getting hung up on that, scrutinizing that and wondering what values are permissible, etc., unless it's all very clearly summarized at the end. And I just want to know, yeah, do we sort of look at the summary? If it's clear enough, we move on, we tick yes, it's okay, I accept the grid impact study, there are no upgrades necessary, or is it more complicated than that?
Mark, thank you for that. I support that. Don't break your head on anything that we didn't discuss. So we didn't discuss any of the simulations in any detail. Not the grid impact assessment, not the strengthening study, not even the grid code compliance assessment. So if you're not comfortable with what you see, rather say no. That's what I would recommend at this stage, and just add the comment that you're not sure about this. And we can discuss maybe quickly what I see when we discuss the results, what I've seen in the reports. So, yeah, this is a real life example. So expect some catches and gaps and questions. And we can prepare what kind of feedback we want to give to the customer to fix whatever is still missing.
Great, let's do it.
Okay, so the Google link has been sent. You should have access to the documents. Please let me know if you can't see it. There's one more document that I'm just sorting out and I will upload now. It's called a response document. But for now, there's sufficient other documents to go through in the meantime.
So just looking at the documents, it's quite an exercise. I don't know if you have any guidance around, should I briefly scan each document first to get familiar with what it is? Or the ones that they should work through sequentially, or you're just dropping us in the deep end? All of this has landed on your desk. Okay, what do you do?
Yes, Mark, sorry, I am dropping you a little bit in the deep end. So, yeah, let me.
Yeah, that's okay. That's okay. We can handle that. So, but if people get stuck, we can ask questions at any point. So that'll all be fine then. Yeah.
See if I can zoom in. That's not going to help. Okay. Sorry, let me share it differently.
Share it through the Google link. It comes up a little bit more informatively.
Okay, let me try that. Okay, so the first thing is this one is the application form. So look through it, and is that acceptable? There is a grid code gap analysis report. So that obviously would fit in with the grid code aspects. Then the test a relay, loading power quality and fault levels. I'm not sure even if that is for the plant itself. There's a process description, a single line diagram, and settings. That would be the protection settings. And there's responses, so that's some communications between the customer, the distributor, and NERSA, if I remember correctly. So maybe the first thing is looking through the entire checklist, which kind of documents seem to be available, and then start going through them and see, but okay, if I look at this, let's go to the top of the checklist. Okay, so there's an application form. There's a process description for the NERSA application. Is that part of the information pack? Evaluation, is there a grid impact study? What is included in that grid code compliance report? And then I think this probably comes to this point. There's something about the power quality and the protection. Is that what the generator proposed, or is that actually from the distributor? If you don't, there must at least be an indication of the communication between the two if you want to, if I would tick this off. If I don't see anything from my colleagues, if I'm the distributor, I wouldn't tick them off yet. Does this help?
Oh, that's good. Thank you, Gerard. Maybe just to summarize, because we've jumped now a bit around. So Gerard, the understanding is we've provided now the Google Drive link. Everybody has access to the resources or the documents relevant to the application for a above 1 megawatt project. And like Mark said, to some extent, we're throwing you in the deep end because that's what's going to happen out in the field. And the intention is to go through those documentation, as Gerard highlighted now, and see if you would be able to tick off the checklist in terms of information, confirmation, or whatever the case might be. And then we can always reflect back to see what's missing or where would we find that. And then, yeah, we are here to ask if there's questions to be asked, or you say we don't find this, or is there any information on this, then we can tell you no, it's not there, or this is the reality if we need information for eThekwini, for example. So yeah, and then we'll give you a Google form checklist that you're going to tick off. But for now, go through the documents and then utilize the guideline document, which we've sent on day one and sent via email, that you can apply what you've learned so far as possible. Is that correct, Gerard?
Yes.
Okay, great. So I think we're going to need some time to go through the documents, so let's give that time. Unless there's specific other questions or comments, even from the C team maybe.
Nothing else for just thinking. We are hoping to draw you into a quick meeting at 12:30. So now we sent an invite. So I don't know if Gerard, you could still be on standby for questions, and for if you could pop into that meeting. It's around the 5-day training. We have lots of applications, lots of new municipalities, and we need to make a few judgment calls.
Sure. Okay. It's 12:30.
12:30, yeah.
Okay, I'll be on standby, yes.
Thanks,
Thank you.
Gerard.